Welcome allemaal. Welcome everybody. This is a great honor to host this. Also to our audience on Teams, thank you very much for joining us. We are slightly tight for time, so I'm going to get this going. Just first, quickly for the audience here, if you've never been here before, the emergency exits to your back. As in the aeroplanes. Bathrooms as you exit to the right around the corner. For our people at home, please grab a cup of coffee. This is going to be super informative. Please take notes. We do encourage you to stay on top of this topic, as especially our customer-facing teams know. This is a pressing issue in the market, and we need to know what we're talking about when we open our mouths. Then just quickly through the program. It's a basic one, but it's going to really serve us very well to manage our time. First, I'm going to call on Johan Bibby, if he can come to the front so long. He will introduce Dr. Thomas and Dr. Dolezal, and then we will have a Q&A session. And we also encourage our teams that is joined online. Please send your questions through. Christian here will monitor and let us know what you have on the heart. And then after that, Steve Nell, thank you then for giving us some closing remarks. That will happen between 12:55, we'll be very specific here, and lunch. With that, thank you, Johan Bibby. Please come.
Thanks a lot, Lisa. Welcome to everybody, and especially welcome to our colleagues from the US, Andrea and Samantha. Today is really about knowledge sharing, and I think with DSO in mind, it really shows how we can work together and we can really cross-pollinate and get the knowledge from people that really can bring value to our business. Our theme for this year, as everybody knows, is innovation through generations. And I think this is also a new generation of disease that we've got in South Africa. That's going to be the main topic today. And we live in an ever-changing world of agriculture, and this disease has come to our path last year and is really changing the way we are working. And this is not only having an impact on our customers, but it can also have a huge economical impact on us as Bayer and on our stakeholders, which is our customers. It's got a huge impact, and how we communicate from now on is going to be really critical for us as DCALP and Bayer. We face challenges every year, and as we face these challenges through drought and pest, having good and thorough communication to our farmer customers is really of high value for us, and how we can bring this information through clear and transparent knowledge from our teams is going to be very, very important for us. Relationships with our customers is built through knowledge, and we really have to bring this innovative knowledge and knowledge sharing to our customers continuously to be valuable for them on their farms. And let's stay the ones in the industry that brings those solutions to our customers. So it's really nice having you here, Dr. Andrea and Dr. Samantha. And before I'm gonna introduce them to you, I really want to ask all the teams that's here and all the teams that's online to be here and take the information and the knowledge that is brought to us and really make it valuable for our customers. The industry at this moment is at a place where they really need the clear, correct information at this moment for the way forward in the future. Dr. Andrea holds a PhD in plant pathology from the Northern Carolina State University, and she has spent the last 11 years employed previously by Monsanto, now by Bayer, as a field corn pathologist in a role within breeding organizations. She assesses the corn pipeline for the disease tolerance, focusing on both established and new diseases, which we've got now. I think it's an old disease for you now, but for us it's quite a new one. And additionally, she engaged with our customer teams and academic institutions to gain insights into ongoing disease issues across the United States. And she's currently based in Northern Illinois. Dr. Samantha holds a master's and a PhD from the Iowa State University, and she has spent 18 years with Bayer. Her current position is within the Regulatory Policy and Stakeholder Engagement Group. Sam works on emerging plant disease issues by working with internal and external partners to determine response plans, diagnostic needs, alignment across trading partners to enable securing, producing, and seed improvement. It's really a great privilege having you here, and we are really looking forward to get all the information we can in this next week from you. And I really want to ask the teams to really engage with them so that we can really almost say the milk again, but we really want to get every little bit of information in this week from you to be more valuable for our customer farmers and the industry out there. Welcome, and I want to call Andrea to the stage. Thanks a lot for coming.
Yes, hopefully you guys can hear me okay. I think I'm mic'd up all right. Yeah, thank you so much for the invite today. Just have a presentation here. We're going to talk through a little bit about Goss's wilt. Let me go ahead and start. I first wanted to give a little bit of history about this disease, particularly for the United States. And one of the things I really want to stress, and I'll say over and over again, is that we've been dealing with this disease in the United States for years, right? And we'll go over some of the challenges that we've had more recently with that, but I just wanted to be clear that this is not an emerging disease for us in the United States. We've been dealing with it for a while, so have some experience there as well. And then I'm just going to hit briefly upon the biology of the pathogen. In this case, it seems like most people have probably read up about this disease because it's here, but I just wanted to call out a few key points, and mainly that's going to help us understand how we manage this disease. So like I said, there are different tools that we can use. Some are going to be more immediate, and some maybe are a little bit more long-term, but I think we need to approach this as a whole and figure out how we move forward with this disease here in South Africa. So like I said, going to start off with the history. So Goss's wilt is a disease of the U.S. So it was originally first detected in Dawson County in Nebraska. And you can see it's smack dab right there in the middle of the United States. It was first called Nebraska leaf freckle and wilt, and as we go through the symptomology, it'll become apparent why that was named that. And they did some research at the time and found out that this is a bacterial disease. So that's another key point here to call out, that this is a bacteria, not a fungus. So when we start talking through that management, I'm not going to talk about fungicides because in this particular case for this disease, since it's bacterial, it's not going to do much for us. So if you feel like that portion of the presentation is missing, it's not. It's just because that's not one of the tools that we use to manage this disease. And in addition to that, so they found it in 1969, and from there they determined that once you find a disease, you're going to see it probably pop up elsewhere. So, but predominantly in the 1970s, they were seeing it in Nebraska. So they found it around, you can see down below there, they have the counties. It did spread a little bit into the surrounding counties of Kansas and Iowa, but by and large it was there, and it was kind of seen maybe as you could consider it more of a regional disease. And then about that same time, they decided to rename it, because that's what we like to do in pathology. We like to continually change things to keep people on their toes. And they called it Goss's wilt. And the reason behind that is there was a professor there at the University of Nebraska who was apparently very well liked. Unfortunately, about the time that Goss's wilt was discovered, he passed away. And so they decided to name this new disease in honor of Robert Goss. Kind of an interesting fact here is that he probably actually never saw the disease. Even though he was a plant pathologist, unfortunately he passed away before that, but they did name it in honor of him. So that's when it got changed to Goss's wilt. So as I said, so they found it in the 1970s. it's one of those things. It's always interesting. It's like, what's going to happen? What does the future hold for this particular disease? And so once again, in the 1980s, they started seeing it kind of reemerge again. Once again, it was really focused in that Nebraska area. You started to see it expand out a little bit more, maybe into Iowa there, a little bit into Illinois. But then again, it just kind of went, I guess you could maybe say, underground until about the 2000s. And then all of a sudden we started to see things change. Once again, Nebraska was getting hit really hard with this disease, but then all of a sudden they started to see it spread outside that region that they'd seen before. And you can see in the map there on the right, we started to see it spread north, even into the deep south, and then a little bit east. And there's a nice paper out there. I don't know if others have been able to see this, read this paper or not. They did a nice analysis on why they thought all of a sudden you're starting to see this disease spread. And some of their key points were, first, it was you had a lot more corn on corn happening there. In addition to that, they had a lot of increased, reduced tillage practices. And once again, we'll get into more of this, why this has more of an impact on the disease a little later in the presentation. They had increased use of irrigation. This is mostly pivot irrigation in Nebraska, which is also going to help spread that disease. They had multiple years of disease-favorable weather. So they were seeing these warm winters, so the pathogen had more of an ability to overwinter. And then they were seeing these hot, dry summers. And then lastly, and I kind of bolded this one because there was a lot of genetically susceptible material that was put into the marketplace by several different seed companies. And that was in part because they just didn't see that this disease was a problem. They'd seen it pop up here and there, but it wasn't causing much damage. So there wasn't as heavy, intense screening going on for the hybrids. And so you had some material getting into the marketplace that was introducing more susceptibility. So one thing, before we move on, I do want to call out on the map is, as you notice, that we do grow corn on the eastern side of the U.S., right? But you can see that it just has never quite made it to the east side of the country. And that kind of plays into it a little bit about how we place our products. And so when we talk a little bit about genetic resistance, I'll go into that a little bit more about how things are placed in the United States based on that risk factor. But I did want to call that out as what we're talking about the map here, that you can see that this is predominantly a large majority of where Goss was seen is in Nebraska, but then also in the other parts of the Corn Belt, but not out east. And then historically, I'm sure you guys have also seen this paper. It was a really nice one that came out just recently, actually, where they talked about, this has been more of a North American disease. So in addition to the U.S., where we're seeing the disease, it also had moved up into Canada. So our partners in Canada also are interested in having disease ratings on our products. There has been a paper come out that it is potentially present in Mexico. There's just one paper just needing just a little bit more information on that. And then unfortunately, you guys made the map here in 2025, and we do have Goss's wilt present here. So first one outside of North America where we've been seeing this disease. Okay, next we're going to transition here to talk a little bit more about the biology of it. Like I said, I'm going to go through this fairly quick because it sounds like you guys have been pretty well versed in what the disease looks like and a little bit about the life cycle. But first, just also wanted to call out as far as like naming. Once again, as I said, pathologists really like to rename things. So as you're reading through the literature, you can see that has gone through some different name changes over the years. So when you see it being referred to something different, it's not a different pathogen. We just have more data on the pathogen. And so we see that the name has changed over the years. But right now, the naming of it is Clavibacter and Nebraskensis. You'll also see it referred to as Goss's wilt and leaf blight. I guess we get a little lazy. A lot of times we just call it Goss's wilt, but the official name is the Goss's wilt and leaf blight. And that's just because you have those two different phases of the disease, the wilt and then the leaf blight phase. Okay, start here quickly with the disease life cycle. One of the key aspects to this disease is that it does overwinter in crop debris. So you have infected plants, the leaves are infected and, they still remain in the field, that's where your initial source of inoculum is going to come from, is from that infected leaf debris in the field. And once again, that'll become more important as we start talking about the management component of it. This is not unusual, right? We know that this happens for our other diseases like northern corn leaf blight, as well as gray leaf spot also overwinters in infected debris, and diplodia as well, that causes diplodia, ear rot, and stalk rot. So once you have this infected debris in your field, this just is a source of the pathogen to be able to be dispersed to the new plants growing in the field. So a lot of times we associate Goss's wilt infection with just real severe storms, right? So you have these real severe storms that are going to kind of splash that pathogen up onto the plant. You've got wind, which is going to help blow it around. Another key component here is irrigation, right? So if you have overhead irrigation, that's also another way that you're going to see that that pathogen being able to be transported to the plant. So with that, once you have that pathogen landing on the plant, then you can start the infection process. And here we just kind of have a step-by-step look of how that lesion is going to develop over time. So a lot of times with Goss's wilt, as I mentioned, it's associated with storms. Why this disease was so impactful in Nebraska is Nebraska has a lot of hail, and their soil is very sandy as well, and it's very windy there. So a lot of times what will happen is you'll just get these storms that we're going to, we call it like a sandblast the plant. So you're having these little wounds in the leaves. And then in addition to that, what hail does. It just can kind of shred the plant, right? So it's just a perfect way for the pathogen to get into the plant. This here, what I'm showing, and I'll show the machinery that we use to create this. This is our inoculation technique. This is where we've done little wounds. We don't want to completely shred that leaf, but little wounds enough to get to allow the pathogen to get in. So as you can see, and most people probably are familiar with, you're going to get that water-soaking lesion. Depending on the amount of susceptibility within your hybrid is going to depend on whether or not that lesion is going to expand. So you can see in this particular case, you have that leaf expansion happening. You start to see those freckles starting to appear, right? And it's very, very classic. I personally think Goss's wilt is easier to identify when it's first starting to develop than when we get into these later stages here. Obviously, once again, susceptibility, you have that lesion starting to expand. You're going to get necrosis in that lesion. A lot of times this is where you're going to start to see the bacteria starting to ooze out. So you're getting that classic sheen appearance to the leaf. Eventually, once again, at the level, depending on the level of susceptibility of that hybrid, it can just take out that whole leaf, and it can take out the whole plant as well. Like I said, I think it starts to get a little bit more difficult to tease it apart from some of the other diseases as you get into those later stages. But obviously, you can still see, especially around the edges of the lesions, you can still see those classic freckles. I did want to call out too, because you'll read in the literature that you can get the bacteria entering the leaf naturally. So this study here, I think, did a really nice job of kind of highlighting how that can occur. So you can see pictured there, you have the bacteria surrounding the stomata. So this can be a natural entryway for the pathogen in there. So they did a spray inoculation. So they just took the bacteria and they sprayed it on the leaf. And then they did a couple different things. They wounded it after they did the spray. So like we talked about, that natural wounding. They did it where they did just increase the humidity. So that's going to open up that stomata to allow the bacteria to enter a little bit more easily. And then just normal conditions. And you can see, and I'm just going to really talk about the graph here on the left. You can see that this is looking at the incidence of plants that are infected. And so you can see that that wounding is very efficient. It just really allows that bacteria to get in very easily. It's the primary method. But you do see, and once again, I do want to call out, they used a pretty high concentration of bacteria here when they did their inoculations. But you can see that plants can become naturally infected without having that wounding. So it's just a call out. I think you probably have to have higher levels of inoculum load and the right environmental conditions, like that high humidity to have this happen, but it definitely is possible, and wounding is not always necessary. Like I said, I think early on, Goss's wilt is an easier disease to identify, but as the disease starts to progress, it can be a little bit more problematic to tell apart. In addition to that, I had the opportunity to just walk a couple fields yesterday. It's very clear that like a lot of diseases, you have multiple diseases showing up within the same field too. So I think that's just definitely one call out to think about. You might have Goss's, but you might also have another disease present as well. I think the one that's most often confused with it is northern corn leaf blight, which you guys do have here. Obviously, northern, once it starts off, it has that really classic cigar-shaped lesion, right? Very, very obvious. But as that disease starts to progress, you get those elongated lesions, which do tend to look like a lot like those Goss's wilt lesions later in the season. And then you can also have abiotic things happening that do look a lot like Goss's wilt. So you can have like nitrogen deficiency. It seems like a big one, and maybe this was a last year for you guys here, that drought stress, because that drought stress is also going to like kind of kill off that leaf, and it can look a little bit like disease, which can be difficult to tell apart. And then also sun scalding. So one thing to keep in mind with sun scalding, I think sun scalding, those lesions tend to look pretty clean. They're nice, clean. That's what we like to call them, clean lesions. They don't look dirty like what you'd see with northern corn leaf blight or with Goss's, where you had that freckles. They're very clean. But just one thing to keep in mind when you're looking at it. I did have this slide here just to kind of once again highlight that Goss's wilt and NLB can be more difficult to tell apart because they're both xylem invading pathogens, so they're kind of infecting in a very similar manner. So that's why it can be kind of difficult to tell apart. But I think as you become more familiar with the disease, it'll become much more obvious which one you're looking at. But like I said, really late in the season, that can be getting a little bit more difficult. With that, this is just the classic trick. And of course, we always like to show you the best leaves possible for this, right? So this particular case, you got a nice young lesion with lots of freckling. When you take that leaf and you backlight it, you can see that those freckles illuminate. It's just a really nice way to kind of help you feel better about that being Goss's wilt. Like I said, when those older lesions, because I remember when I was first getting comfortable with the disease, you'd hold up what you knew was a Goss's wilt leaf, and you'd be like, I don't see any illuminated freckles. A lot of times they're going to be more at the margin of that leaf because that's the younger part of the infection, and so that, yeah. So it took me a while it was really frustrating because I was like, why am I not seeing the freckles? But just look at the margins of the leaf there. One thing I just wanted to highlight real quick too, because we do, want to feel confident in what we're seeing that it is Goss's wilt. One of the things that's very nice to use in the field is the Agdia immunostrips, and they're very fast and easy. I am sure several in the room have actually used these before. You just take some leaf tissue, you put it in the bag there, you kind of scratch up that leaf, and then you put like the immunostrip in there, and it's just going to read out the results on it. But we do have to be careful. This, and Sam, I don't know, you're going to do a much better job explaining it. Do you want to go into a little more details about some of the challenges with this immunostrip, some of the pluses and the challenges?
So on this, as you can see on the screen, it was actually, this strip was developed for a Clavibacter that infects tomato. The thing about bacteria, immunostrips are made to a protein. And the Clavibacter protein for michiganensis turns out to actually be broad, and it will work with many of the Clavibacter species. So we asked our diagnosticians in Woodland, who support our vegetable business, could they look and see if there would be cross-reactivity with the Nebraskensis as well. And you can see here, so they actually did this work, I think it was late last year. You can see, corn tissue, because actually Matt did some survey work with you last summer. He had some tissue available, looked at it. It does cross-react. The way that we view these, even in the vegetable business, is it's indicative. So it could be Clavibacter that's present, but we also know that this strip will cross-react with other non-Clavibacter, non-pathogen bacteria. So what it can tell you for sure is that Goss's may be present. If you get a negative, Goss's is not present. We do know that, yes, if it's there, you'll get a positive. If it's not there, you'll get a negative. But is that positive solely from Goss's presence? We don't know for sure. So our guidance would be, it's a way to figure out, particularly with the NLB here, or Goss's, do I have to spray or not? Because one of those you can apply a fungicide for. This one will tell you what's potentially in my field and what should I do. On the Goss's, you're going to talk about the management a little bit later. We can't spray for it, but here it's an indicator, okay? It's something for you to kind of watch and use. And we were talking with Naki about potentially setting up the diagnostic capability. I know she's out on leave right now, but other labs around the country may be able to do a more confirmatory testing. And tomorrow we'll talk, some of our meetings are with the government as well as Sansor, and we'll talk about what sort of diagnostic they would prefer, because as Bayer, we do like to stay in alignment with what they recommend. Okay?
Absolutely. Thank you, Sam. Okay, next, talk a little bit about as far as when infection can occur with this disease, and it can really occur at any stage. And what does that mean for the plant? So if you have this really early infection, so it's happening at that seedling or just as it's coming out of the ground, it can be quite dramatic. So this is where you get that systemic infection. So the bacteria is actually moving into the plant, into the stalk, and it's infecting systemically throughout. And as a result of that, the plant gets very, very sick. And it's a lot of times you'll see these systemically infected plants, they're very stunted. A lot of times they can be barren. And it's really, we'll talk about it in a second, it had just dramatic effects on yield. As the plant starts to mature a bit more and you have that later stages infection, that it's not quite as severe, although if you still have it when you're in that vegetative stage, so like more like V6 or V8, it can still have quite a bit of an impact because that just is the pathogen's there. It's allowing that pathogen to have multiple cycles in the field, and a lot of times if you have susceptible hybrids, this will really start to show up. As you move more into that reproductive stages, you guys are familiar with this with our other foliar diseases. A lot of times they're just not going to have as much of a yield impact. They definitely can, but as you move later into the season, you start to get into where it's going to be more of a cosmetic issue. And then also in addition to that, thinking about the inoculum load for the next season. So really just the take home here is that infection can happen at any stage, and the impact on the plant is going to be different depending on when that initial infection took place. Obviously, that initial infection is important. Weather can also kind of change things, the susceptibility of the plant, but that timing of the initial infection can really drive how severe of an infection you're going to have. As far as like the impact on yield, this just kind of is a graphic highlighting how that might impact things. So if you look, like I said, if it's happening super early, you can pretty much say you're not going to get any yield on those particular plants. As you move into that V6 to V8, you can start to see that if you have resistance or tolerance in your hybrids, you're going to be okay, even at that earlier infection point. But if you have material that's going to be more moderate or more susceptible, even at those earlier stages, you are going to see some level of impact on yield. And then kind of similar story as you get into that V12 to VT. Once again, it's those really super susceptibles and the moderately susceptibles that are going to have some yield penalty with this disease. And then the graphic on the right just shows you, once again, later stages, not as big of a deal, but you can get hit a little bit if you have a large amount of susceptibility. So if you look in the literature, they've done a lot. It really comes to, it looks like about 1.5 to 5% yield decrease for every rating that you have. And we'll talk about the rating scale here in just a little bit, but it's that the level of susceptibility of your hybrid will dictate how much yield loss you're going to have. And there's, like I said, I pulled out one that was more recently from 2021. It just highlights once again what we were discussing here about as far as that earlier stage is having the biggest impact on yield. You can see there they were saying for susceptible hybrids, you could have upwards to 34% yield loss with those hybrids once you have that infection occurring at V6 to V10. Okay, and I think that we've almost gone full circle around the disease cycle. Once again, just to highlight that this is a polycyclic disease. So once you get that initial infection, you're going to have that bacteria oozing out of the leaf, which then will get splash dispersed again. So the cycle kind of repeats itself within the season. And that's where you kind of get the disease building up within that field if that infection is happening early. I do feel like that this disease likes heat. We do see this in our inoculated trials. If you don't have heat and you don't have storms, a lot of times that disease kind of stalls out, as we like to say. So you'll see it there, but if you don't have that right environment, it's not gonna move and have as much impact. Which in our inoculated trials, we want it to do that, but obviously in a grower's field, we don't want that. So yeah, the environment does play a role. Maybe not quite as big a role as some of our fungal disease, but it definitely helps drive this disease. I did want to touch just a little bit on other hosts for this disease. We definitely think of corn as the primary host for it, but there are a lot of what I guess we can consider secondary hosts. So a lot of the grass species there, I'm obviously not going to list all these, but I do reference a paper there if you want to go into more details to look at what specific ones. And honestly, this is probably not a comprehensive list. I do imagine that there's probably other grasses out there that do have the ability to also become infected as well. But this just lists out, and it's a good thing to keep in mind as we talk through the management part of this disease, to keep that in mind, that it's not just corn that can get infected. There's also these other grass species. In addition, just to make things more complicated, in addition to having ones that can serve as a host. So as a host, that means that you're actually going to get the bacteria we just talked about, infecting the leaf and causing lesions. But we do know that there's potential other hosts or what we maybe consider reservoirs where the bacteria can just live on the surface of leaves. So things like maybe wheat, oat, those kind of things, those can also serve as kind of reservoirs for it, but they're not considered maybe what you call a host because they're not actually going to infect the plant. You're not going to see a lesion. They're just going to be growing on the plant. But they can also be a source of inoculum for fields. But I do want to call out, even though they are a source, so probably you're not going to see this increase of inoculum load probably from those other secondary hosts. So this paper here is looking at different inoculation concentrations. So if you look at the bottom, they're spelling out the different, so it's going from least concentrated to most concentrated. And then they did inoculations on susceptible corn, moderately resistant corn, and then we have some of the other secondary hosts like ryegrass, foxtail, and Johnson grass. And then after that, they just kind of looked at that lesion length. And you can see obviously with the susceptible corn, that's where you're seeing the largest lesions develop. That's where you're going to have the most potential for inoculum for subsequent seasons. In the moderately resistant, you can see that lesion size is reduced, which makes sense. And then, sorry, I should have called out too that this was 2 biological repeats. So they did the test one time and then they went back into the second time. And for some reason on the second time, the moderate had a little bit more larger lesions. But you can see, I think the take home here is that the others, the ryegrass, the foxtail, and Johnson grass, still got infected, right? But the lesion size wasn't as big. So definitely it's going to still be carrying that pathogen, and it can be a source for the field, but it's just not going to be as much bacteria present in that leaf tissue that can carry overwinter through. That could overwinter and then subsequently potentially cause infection the subsequent season. So, okay, now we get into the management practices for Goss's wilt. Let me just take a drink real quick. And of course, as a pathologist, you can't have a presentation without showing the disease triangle. I know non-pathologists get really annoyed with this, but sorry, I couldn't help it. So obviously, as we talked about earlier, in order for the disease to occur, you have to have a host that's susceptible. You have to have a pathogen present. So obviously, if you have a susceptible host in a field that doesn't have the pathogen present, you're not going to get the disease to develop. And then in addition to that, you also have the right environment. And I grade out environment because there's not much we can do about environment, right? So what we're really going to focus on as far as management goes is the pathogen and the host. And so what I'm going to talk about first is a little bit about how we can manage the pathogen in the field. So I think one thing to kind of keep in mind too is how the disease typically develops, right? So a lot of times you're not going to see a field like what you see at the bottom of the screen here to start with, right? So you're not going to just have a field that's just obliterated with the disease. So you can see there in that lower picture, all that's kind of discolored there, that's dead from disease, right? What's going to happen more likely is you're going to have a buildup of that inoculum over years, and then you can have the subsequent happen. So in those top pictures there, you can see also little pockets of discoloration, right? So that's where that pathogen was present. It was able to cause infection, and then you had that disease spreading within these little spots within the field. Now this can be kind of deceiving because you can imagine you're probably not going to have a huge yield loss associated with this, right? Because it's just focused in these small little pockets. However, it's a source of inoculum, right? So if you put corn back into that field again, you can imagine that the cycle's just going to continue and continue, right? And so those spots are going to grow in that field, and that's when you're going to start to see yield impacts happening. So you might have a hybrid that's say rated a poor for Goss's wilt or moderately susceptible to Goss's wilt, that you're thinking, hey, it looks okay. I'm not seeing that much yield loss associated. I had the disease in my field. I'm not seeing that much yield loss associated with it. But what happens is if you continue to plant corn in that field and you continue to maybe plant that same hybrid that has some level of susceptibility, all of a sudden that hybrid is going to look potentially worse in subsequent years just because you have that buildup of inoculum. And this here is just kind of reiterating that point here. I just kind of liked this paper. It helps me visualize things. It's very busy, and I apologize, and it's probably really hard to see on the screen. But what they did here was just kind of look at the spread of the disease within the field. So think of so they had two different years, 2012 and 2013, and then you can see here they had plots. So think that this is a field, and then where those white spots are is where the border is. And so what they did in this field is they went in and they did wound inoculation. They did where they just placed residue in the field, and then they had one where you had no inoculation occurring whatsoever. And then they just tracked. They went out there to these different spots in the fields, and they just tracked to see where they were seeing disease show up in there. And you can see that and then the color depends on where that disease was happening. So you have red, it goes from planting date. So red is the earliest infection all the way to dark blue where you have harvest. So you can kind of see how that disease is spreading over time within that field. And you can see that the wounding is going to cause that earliest infection like we talked about. It just is a nice entry point for that, and it's going to be the most severe, and then you can start to see it spread out. But I think the important point is like in 2012, even in that non-inoculated, you still see that disease spreading, right? So the disease does spread, but it's going to happen over time. Okay, so what do we do to manage this disease? One of the big things is just to reduce that inoculum load. So I keep talking about it's overwintering. You can have buildup of inoculum happening in your field. What do you do about it? The easiest and the most readily available is just simple things such as tillage and rotation. So you can imagine when you're tilling, you're taking that debris and you're burying it. And we know that with that burying, the survival of the pathogen won't survive as well, right? In addition to rotation, you're breaking up that cycle. You're taking a year off, and it just knocks down that inoculum load. So if you were to go back into corn the following year, you're not going to have as much inoculum there, and hopefully you won't see the disease showing up as much or as present. So I think those are the key things that you can do right away if you see Goss in a field to think about for the subsequent season to help minimize your risk for the disease being present. The next thing is if you do see, like we talked about, you see those localized regions, and this is easier said than done, I realize, because there's some really big fields out there. But if you do see like hot spots, if you do have the ability to just simply kind of remove those plants. But when you do that, you have to be very cognitive that you don't want to be spreading the disease through the field too. So as you remove, just make sure that you bag it and that you're not just spreading the disease inadvertently by tracking it through the field. But that's like just if you start to see it just beginning in a field, it's a good way to minimize that. And then I also put on there, as we talked about, there's these other grassy secondary hosts that we can think about. So just like weed control, right? So just make sure you're kind of knocking it back if possible away from the field so you don't have this like reservoir of the pathogens surrounding the field or even encroaching into the field. If you can minimize that, then that's also going to hopefully prevent the spread of that disease into the field. So these are just things that you can do. The next thing that's probably going to be the most effective is just host resistance, right? And that's what I'm really going to try to spend the next part of our talk on, is just talking about host resistance, how we identify it, and what we're doing currently to try to speed up that process. So host resistance is great, right? We saw as far as like yield loss goes, if you have host resistance, you're going to minimize the yield impact on that hybrid when the disease is present, and even under severe conditions. So you can see here on the left leaf, you can see you have that initial inoculation point happening, and you don't have anything happening, right? You see little bits of the pathogen starting to infect, but not much. But then you have a leaf on the right there where it's just really infected, right? So just having genetic resistance there can be really, really powerful in helping to control this disease. And I think most people here are probably familiar with our 1 to 9 rating scale. This is what we use for northern corn leaf blight, right? So this is nothing new. We do very similar. We rate the two diseases very similarly. So as I said, this is being overwintered in the crop debris, so a lot of times you're looking at that bottom-up development of the disease. And so what we're just looking at is how much of that plant is infected, and then giving it a rating. So obviously, if there's very little infection, we give it a 1. Heavy infection is going to be a 9. This here is what it looks like for Goss's wilt, and I think that this is really important to realize how bad Goss's wilt can be, right? So obviously you have 2, 3, 4, you're going to see that disease showing up, but it's going to be maintained at ear leaf level or below. Once you get into more of a 5 rating, this is when you start to see that disease being able to move up into the upper canopy. Historically, we've always treated it in the United States that at 4.5 and below, the plant can tolerate it a little bit better without having any sort of drastic impact on yield. But as you start to move up the rating scale from 5 beyond, you're going to start to see that impact on yield if you have the right environment present for it. But I will say, so like if you look at 7, 8, and 9, I will say that we did have some products that were rating that high in the United States in 2010. So there were some pretty susceptible products out there, and this is why you were seeing some issues in the 2010s. So Goss's wilt, the resistance is quantitative. We have it on both the males and the females. And so what you see is you can see a range of different reactions depending on the level of tolerance or the level of genetic resistance within that host. So most of the time what you're going to see is a bell curve, right? So you're going to see very few products that are really good and very few products that are really bad. You're going to have a lot in the middle. Sometimes that curve, that bell curve, can be more narrow and sometimes broader, and sometimes you can shift it, but this is typically what it looks like. I wanted to point out, and maybe I should have made it a little larger because it's really hard to see, but this is from our advancements for this season within the U.S. So this is RM 110 through 120, and you can see this is what our distribution of our P4s looks like. And we've spent a lot of time shifting our rating, shifting that bell curve more towards the lower end of the rating scale. You can see on average, we did have a rating of about 4 for a lot of our P4s within this RM range. But you can also say, I want to point out here, we don't have 1s and 2s. We just don't. And that's partly because we're also advancing on yield too, right? Like we're advancing on yield. So we want to have just enough level of tolerance in there, but also have high yielding products. So you can see most of that is focused around 4. We do have some that are a little higher, and that is part of that product placement conversation. We send those out east. They're not going to Nebraska. They're not going to that high risk area. We're sending them east. So we do have a range of reactions, but we try not to go above 6. Like that's like, even if it's going out east, if it's coming in at like 6.5 maybe, but like anything, but it's just, we just don't even want to go there. So there's been, since the 2010s, there's been a lot of effort on Goss's wilt. And it's actually quite impressive how quickly they were able to take screening and make it really high throughput. Because that's really what improved our pipeline, was just doing Goss's wilt screening in the field. If you look back in the literature, this was not a new measure. We knew that we could inoculate for Goss's wilt, which is not the case for some of our other corn diseases. But for Goss's wilt, we knew that there was effective methods. And at the time when things were starting to get bad, they were doing inoculations by using a cheese grater and using bacterial spore suspension. So you would literally dip your hand into the bacterial spore suspension, take a cheese grater, and then just in between the plants go through. Younger people did that because it's really hard on your back. But as the team started to get older, they were like, this is kind of not what we want to be doing. So I guess they did invent the clapper. So at least it's nails and 2 boards and then a sponge on the other side. So you dip it in and then you clap it. Very simple too, but it was better because at least your hand wasn't getting pummeled. And then they're like, we can't do this anymore. We can't just keep bending over. So they just put it on one of those like little reacher grabber things. And then you could just put the clapper on that and you could stand up and inoculate. But the team was being asked to evaluate all stages of the pipeline. So from screening to all the way to commercial, which is a huge number of plots. And even with the stand-up clapper, that was not going to happen. And so that's when they started investing in what we call the grit blaster. And it's really what we're trying to do with all these inoculation methods is just simulate what we do for what happens in the field with that grit blast or with the sand damage and the hail damage. So I do have a video here. This is the grit blaster. There's no volume to it because it's quite loud. But really what it is just corn cob grit that's getting sprayed on the plant. And then there's a bacterial suspension that's being sprayed on it. And so this allowed for way higher throughput inoculations for this disease. Now, it does look pretty intense, right? And honestly, typically we'd inoculate a little bit later, probably more like at V6. But this is just showing you what the machine does. But the idea is, like I said, not to like kill the plant with inoculation. They will grow out of that. It looks a little harsh, but they'll grow out of it. But yeah, you don't want to shred the plant up too much. But anyway, what that allowed us to do was to just increase the number of plots, right? So over the years, as more and more stations got grit blasters, we could start to increase that plot load number, and we could start to be able to evaluate the entire pipeline. So in 2015, this was our number 1 disease in the U.S. Number 1 disease, and we were screening over 200,000 plots for this disease alone. And so what that allowed us to do, though, was to really set up kind of thresholds and not allow anything that was super susceptible to be advanced through. And so you can see here, looking at the graphs, this is looking at the different percent of hybrids that were below a 4, below a 3, and below a 2. And you can see, like in 2011, for, say, the greater than 105 RMs. You can see in 2011, there was only 15% of hybrids that were even below 4. And then you can see that over the next few years, that drastically increased. So that was, once again, all due to screening and to having those conversations about what we were going to advance through the pipeline. So some pretty rapid selection and changes that happened very quickly due to being able to get more disease data. So one of the other things I want to call out as far as the pathogen itself, if you look in the literature, there's a lot of papers and they've done a lot of sequencing of this pathogen. And so the more sequencing you do, the more differences you're going to find. Mm-hmm. But what do those differences mean is another, I don't think we can fully figure it out. If you look here in this particular paper, I liked it because they did try to break out the pathogens based on how aggressive they were. And really, honestly, what it was is they just inoculated and once again looked at that lesion length, right? And then they sequenced them and to try to see, could you identify different clades or different groupings of the pathogen that would tell you that they're more aggressive or not. You can see they're kind of scattered throughout the phylogenetic tree there. So that being said, we know that there are strains that are more aggressive than others. But what we have found, at least in the United States, is that any sort of differences, the resistance holds. So, for example, here we have inoculated trials. We have 2 in Nebraska, 1 in Iowa, 1 in Minnesota, 1 in Illinois, and 1 in Canada. And what we do is we use local isolates. So these are all different isolates from that particular region, and that's quite a big expanse from Canada, down to Nebraska and over time. You're looking at a fairly large region. What we find is we get good correlations between all of our locations, even using different strains of the pathogen. So I think this becomes important as we start to talk about how do our ratings in the U.S. compared to potentially your ratings here in South Africa. We're trying to dig into that a little bit more. I don't have an answer right now. But my hunch, my guess, and I'm probably being recorded so we can come back and say I was wrong, but my hunch is that they'll be pretty similar, right? We've already seen some of the genetics that are in the United States here in South Africa. We knew genetically they were more susceptible to disease in the U.S. We're also seeing them be more susceptible in South Africa. And then just from those different strains, what we see in the U.S., that resistance seems to hold. So my thought is, if I were to guess, they're going to be pretty close. But we just need to see how it all plays out. So I think that's a big thing over the next year, is to really try to tease this apart and have confidence in that to understand things a little bit better. Because there's all going to be all different types, like all the sequencing work. You can do all the sequencing work you want. There's going to be differences. But ultimately, we just want to know if our tolerance is going to be effective against all those different ones, different strains of the pathogen. So something we're working on. One thing to also point out based on some of the work that we've done in the U.S. is that if you have resistance, it's going to be effective throughout the entire life of that plant. So that resistance is effective as seedling as well as the plant ages as well. So something to keep in mind. So what we always try to do in breeding is 2 things, especially for diseases that are emerging or we need to make improvements on. We're going to focus at the early stages of the pipeline, and we're going to start doing selections, right? So we have in North America, we have all these selection indices. Goss as well is part of our selection indices. So at that early stages of the pipeline, we're really trying to get rid of those super susceptibles out of there and bring some decent tolerance through with yield. That's the key thing, right? There's a lot of, sometimes as pathologists, we get so focused on disease, right? That's what ultimately we care about. But there's all these other traits, like lodging, root lodging, green snap, all these things. So we want Goss's wilt to be one of those within the index that we're selecting for, but not the only thing. So there's been a lot of improvements in for some of our diseases by adding the selection in at the earlier stages. And Goss's wilt is clearly part of that selection process in the United States at those earlier stages. But obviously, we want to make sure that we're providing accurate ratings to our commercial team. And so we're providing, you guys are familiar with the 1 to 9 ratings. That's exactly what we're doing. You guys are doing for northern cornleaf blight. That's what we do for Goss's wilt. It's the same thing. We're wanting to really characterize our hybrids and to make sure we're providing accurate ratings so we can give to agronomists and growers to know what kind of risk that they have. Because as you saw, when we're doing our inoculations, they're pretty severe. And so the ratings that we give are kind of what we consider our more worst case scenario. So there's just, we still, I would say Goss's wilts, like I said before, where we had those 200,000 plots, we're not quite at that level anymore, but Goss's wilt is still an important disease for us, and we still screen for it, and we will always screen for it because there is no chemical control for it. So it still is a very important disease for us, and so we're gonna continue to make sure. Lastly, I'm not sure how much time we have left, but just a couple of things to think about is really what is that level of resistance you need or level of tolerance you need. And like I called out before, for us, when you go east, you don't need that much. So we don't worry about it as much. So we just need to really understand the different regions and how much risk there is for the disease within there to know how much level of tolerance you need to be able to get away with. So obviously we're not going to put a susceptible in Nebraska, but we might be able to get away with it if it's got a lot of other great agronomic features, great yield. We can place that slightly different, like out east where there's not that much risk for it. So just really having good characterizations, knowing what that level of risk is, and then how we're going to place it. Because I think that's really key. Like I said, hopefully we give a product a rating of a 5, right? Hopefully a grower never sees that, right? Hopefully in most years the pathogen inoculum load will be low. You won't have quite the right environment, and so hopefully most of that time that hybrid that's rated a 5 is going to look more like a 2 or 3 in the field, and that's what we want to see. But our ratings are under inoculation, they're under high, we place them in locations where you're going to get good disease take. And this is obviously what we say is potentially the worst that you're going to see with that hybrid. But obviously you can have the perfect storm, right? And so you can have certain circumstances where that hybrid actually might look a point greater, but there shouldn't be huge changes. You shouldn't see a product that's rated as a 5 suddenly showing up as an 8 in the field. So just kind of keep that in mind. So, and lastly, I'm going to leave it to Sam to talk about the seed health component of that.
So what I didn't put in, I realized when you read my bio, Sam Thomas, plant pathologist. Actually, what I usually say is seed pathologist, plant pathologist by training, seed pathologist by trade. I've worked on seed-associated pathogens my entire 18-year career in the company. I started in our vegetable business, then went to a global business or global reporting, and I still sit there. So, as you know, this can be a seed-borne disease. From a regulatory standpoint, frequently then what we see with governments is if it can be seed-borne, then we'll just regulate the seed, and that's kind of an easy fix, and we move on. Obviously, the problem here is it's already present within South Africa. So at this point, as Andrea talked through it, really the most important inoculum is going to be what is maintained in that field season over season. So it can be seed-borne. Could seed have brought it in? The answer is yes, it could have. At this point, based on what we know, we won't really know what the epicenter was, where it came from, because it's likely been here, from what I'm gathering, probably 7 to 10 years. And this is what I've done for a living for almost 20 years now. So the seed transmission rate, we do tell growers everywhere, it is very low. It occurs sporadically, right? Again, under the best case scenario, you'll get, it's like way less than 1%, right? Than that. So, but if you think about it, you got 1 million seeds out there. Could that happen? Yes. Are you going to see it, though, in that first year? No, you'll have like one plant out there that may have it, right? So it's very low. It will, though, if you do get seed transmission early on and into susceptible material, because remember, genetics matters as well. Then you can get that systemic infection, and the plant actually won't even make an ear or anything. It will die very quickly, very easily in the field immediately. So again, you think about the inoculum that may be there. As that dries down and kind of withers away, it'll be very low year over year. What's important, and part of our talking points, is we do produce. So frequently, part of my talking points to growers is you need to understand where your seed's coming from. You need to understand how it's produced. With our row crop business, obviously these are open field productions, right? But what's nice about this situation is the productions actually are in South Africa. And we do have oversight of those. We're looking at them, thankfully, knock on wood, hasn't been found there, right, to date. And that's very important for us in our communications back to our growers. So while it can be seed-borne, is seed likely to be a factor going forward? Probably not, because of how we produce our seed here today. But that said, we can also talk about just how we can maybe manage our own production sites a little bit better to continue to keep that risk low. So I sort of deviated from the slide a little bit, but catered it to you who are, more of those grower-facing teams, internally-facing teams who have been facing a lot of questions. So, any questions?
I guess it's Q&A now.
Rotation crop, any broadleaf crop, will that be fine? Soybeans or something like that?
Yeah, typically what's being done mostly is soybean, but yeah, any broadleaf, anything to just break up that cycle.
Okay.
Is gonna be
And then you say chemically there's nothing. In South Africa, we control bacterial diseases with copper on tomatoes. Will copper have an effect?
Both of us had a deep sigh on that.
Well, let me back up and say, so fungicide is not going to, if you have a susceptible hybrid, fungicide is not going to save it from Goss's wilt, right? But it can improve the health of the plant. And if you have other diseases present, like northern corn leaf blight, it's going to help control that, right? Give a little bit of health, and it might look better in the field because of that. As far as the copper goes, I haven't had experience with that in corn as far as that goes, but I just know that that's not something that we've been using in the United States for the control of it.
Leaning on Stephen's question there, obviously I've been reading a lot lately about the biological control of Goss's wilt. What's your feelings around that? Is there something in the pipeline or light at the end of the tunnel? Do you think that it would ever become a commercial viable option?
So maybe I'm biased because I sit within our breeding organization. My thought is I think you're going to be able to turn it around a lot faster with genetic resistance. We know we have genetic resistance in our pipeline. I think, it sounds like that there are some products already out there that are doing better for Goss's wilt. So to me, that seems like maybe is a quicker turnaround. Obviously, biologicals have always been looked at, but as far as, once again, what's been done in the U.S., it's been more genetic-based control.
I would just add, never say never.
Right.
Right? I mean, this is an area where we would be looking at it, but I think to her point, what is the more likely solution in the next 5 years is the genetic resistance, but could there be a product that's added to this that takes your 4.5 down to performing like a 3?
Right.
Something that we can look at when we think we might have something. I don't know that we're doing any work today on any biologicals around this particular target.
No.
Yeah.
Just because we had the genetic control is where we've been.
In the production sites, we know that your lines are more susceptible to diseases and so forth. So in a production site, if I'm a farmer, how do I know that your seed is clean, that your seed doesn't contain any bacterial, how sure? So I think the question is then, if you pick up Goss's wilt in the production site, apart from just impacting your yield, of course, it should impact your yield. Can that, when that crop is harvested, that seed is harvested, that seed can contain the bacterial inoculum, and then that is a way that it spreads through the farms. I think somebody's looking for a culprit, somebody's looking to play the blame game. So are we 100% clear that we can explain to the farmer, listen, the chances that it came from a local production is 0, or there could be a possibility that something could have gone wrong here?
I knew you'd be looking at me. I'm a scientist. I always say there's always a chance, right? But if we look at what has gone on here, to Andrea's point, we're putting these in the field. It's carrying a certain resistance, so we're going to expect a similar performance in our own fields. So the question I would come back to you with is, what are we doing in those fields that we are assuring ourselves that everything looks good? Are we just trying to hit a certain yield target, or are we doing actual sort of our own inspections, our own walking through? I'm sure that you are, because production doesn't just drop plants. I spent 16 years of my career actually in the product supply part of the business. We don't just put plants in the field and walk away, right? No, we're actually in there throughout the season saying, is everything okay? Because you're looking for a predictable yield number, right? And you kind of look at how the ears are developing, the plant is developing, how's the stand going, right? All of that information can actually be put together to talk about, it's not just throwing the plants in the field and hoping for the best once the combine comes through and everything's dried down, but what are we doing about making sure that production is okay, right? And a lot of times it does come back to us to do that work. Why? Because if we ask the local governments or any other kind of crop inspection service, they frequently don't have the bandwidth to come through and do that, right? So it's going to come back to what are we doing to make sure that those processes are going well. Obviously, if we do not have Gosses on our fields today, you could take a step back. We're both pathologists, right? Let's look at prevailing winds and how things move. You have to prepare for, what if I'm seeing something different, right? So what does that escalation look like? What does that diagnostic process look like? How do we work through it? And then how are we going to manage if it, or I guess when it, hopefully it's an if it, but if it occurs in that production, right? I think it would behoove us at this point to get a little bit ahead of it and think about, what if it were to show up, what could we do, right? So I think we're both happy to have conversations this week. I don't think it's on our production or on our tour plan to go and see production, but if we want to have a conversation with the team and talk about what could be done, talk about maybe what diagnostic needs, those immunostrips work really well. Actually, on the vegetable side of the business, many of our sites just have those available, right? Because it's a first line. I can sit here, I can do kind of a preliminary assessment. I can figure out, do I have to spray a fungicide? Do I have something else going on? Hey, if it's not NLB, should I be sending that to our internal lab? I think now is the time for us to get those processes thought through so that we can then go back to the customers and say, listen, it's not here today, as far as we can tell, right? But this is what we're doing to prevent it and to manage it in our own areas as well.
Maybe a question also on the weather. So part of the triangle you said, climate is very important. So you might end up in a following year where you don't see the disease at all. What's that exact weather conditions that's conducive spreading the disease? You said hail and wind and so on, but temperature-wise, humidity, what's important for the disease to actually develop?
Yeah, so I think for this one, it's going to be like higher temperatures. So, and I apologize, I don't know Celsius, like around 80 degrees and higher is typically where you associate it with. But it's, as I mentioned earlier, it's like just storms, right? Like you need to be able to get that pathogen to move around, and by those storms, you're going to have more potential for wounding, which is going to open up an avenue for the pathogen to come in, and it's also going to be an avenue for spreading. So to me, it's like any sort of environmental conditions that are going to build up more likelihood of more severe storms, and then like I said, just that higher heat tends to help drive it to anything above 80. So it's a little different than fungi because they need to sporulate, right? You need to have spores to get the pathogen to move, and a lot of times you have to have the right environmental conditions like humidity to get that sporulation happening and for movement to happen. It's bacterial disease, so it's slightly different in how that develops, and it's more about wounding and just splash dispersal.
Yep. The 80 degrees Fahrenheit is 26, 27
Thank you.
Celsius. Thank you. Jacques, you wanted to add?
Yes, I just want to add to the question of because it's just if you look at the US, the corn growing areas, climatic environment east and west, just like shortly, how do they differ there? To take it into comparison to where we actually are in South Africa, how east and west here differs. Yeah,
so honestly, there's a lot of environmental differences between Canada and Texas. It's like a huge range, and the bacteria does fine. So I think that there's the Appalachian Mountains too that can kind of inhibit movement to a certain extent. But as far as like the environment being different, and my thought is that that's not really what's driving that delineation, is not so much the environment. It's more you just got the mountains there, and it just doesn't make it across.
So the reason, well, the thought process is our customers' sentiment currently is, I don't have Gosses on my farm.
Yep.
So the only way it's going to get you is through seed.
Yeah,
And the only way it's going to get you is I'm buying 100% decal, and if I find it in my field next year, it must have come through your seed. So
Yeah.
how do you mitigate that kind of thought process, I guess?
So luckily I joined the company when things were on the up and up for Goss. But I do think that there was some conversation around that when we started seeing Goss show up in areas like in the deep south, right? Like, how did it get here? And there was some discussion around what was seed part of that transmission. But I think it's just it's one of those things that it's going to move more efficiently other ways than the seed, right? Like, you see leaf debris being blown around. There was some talk too about in the United States, they were transporting some machinery. You know, there could have been like leaf debris in the machinery. That's honestly going to be a more likely route that the disease is going to move versus a seed. But it's always hard when all of a sudden you see that disease in a field that had never been before, and the automatic knee-jerk reaction is always going to be seed. And it's hard to convince people that most likely not. Most likely it blew in, but it's just, I think it's an ongoing conversation, and just getting more comfortable with disease and having those talking points about production to be like, we have these safe measures in place.
Yeah.
We really feel strongly that this is not coming from
And
the
this, I
seed.
mean, this is what has kept me busy for 18 years, to be quite honest. And this company is, when I came in, we actually do have, because our vegetable business is global. It's not regional. We will produce tomatoes in Chile and send them to 37 different countries all over the world. So the amount of environmental differences that they see is quite expansive. So then how diseases will manifest if they're on the seed, highly variable, right? And this is, it's not only just the governments who say if it can be the seed, it will be, and I want a solution, but also the growers as well. I think in this situation, to Andrea's point, you really got to talk about if it's present, how do we kind of, to the regulators, it would be how do we manage that hopefully to a lower level. Some of these practices, you know, crop rotation, deep tilling, maybe not every year, every couple of years, right? Just to make sure that you're breaking it. And it also helps with other diseases. Just putting in these best management practices will help quite a bit to manage it down, right? What we can talk about is we don't feel the inoculum's coming from us because of where we produce and how we produce, right? And that's really the only thing that we can say. But then to encourage them to ask that of all the seed companies that you're buying seed from, right? And this is not an uncommon talking point for me to give to either our veg business or to our row crop, because it is, we do produce differently than others, which has mitigated our risk, right? And frankly, then the risk to the growers as well. But I would say there's really no way of knowing for sure. The other thing is, and we spent yesterday looking at some fields as well. In my experiences, growers will accept maybe to about 10 to 12. As soon as it crosses about a 12% disease incident of what's going on, that's when they're like, wait a minute, something's different, something's major, what happened now? By that point, it's probably been there 3 to 4 years, right? So that's something else, is just to encourage them. If you don't have it, scouting will go a long way, right? And what they're doing. And because it's going to come in from the outside, it's walk the edges of the field, right? Really look at those first couple rows. You don't have to go all the way into the center, right? No, but just what's going on the outside, and follow those prevailing winds.
And the other question was not only because there was at one stage, there was something going around like burning the fields. Is that still something, or is that something that will contribute to spreading more?
Ooh, I mean, if you burn it effectively, I think it would probably kill it off. I guess. I just, I think it would be effective.
The problem with burning that comes up sometimes is you can actually end up with quite a bit of just kind of fine particulate matter that hasn't been burned that then floats away. And so basically it can end up, while perhaps reducing the inoculum in the field, it could end up being a spreading pattern downwind effectively. But I don't know that it's been looked at heavily on how, on what the impact would have.
Right.
I mean, if it's something the farmers are into, maybe, because it would not be a practice that's applied throughout the U.S., but do you get a university or someone to look at that as a potential management? That it could be investigated, but just I would encourage that you look at what is released and could that be problematic to neighboring farms?
Okay, so we have another question from the online participants. So the question is the perfect environment hot and humid for Goss's wilt, and will it go dormant in very dry and hot conditions?
No, I don't think it will go dormant. I think for a lot of our fungi, that hot and humid is really what kind of drives it. Like I was saying earlier, for Goss's wilt, it's going to behave slightly different, and even though it's hot and dry, it's not going to go dormant. Like if you have some sort of wounding and you have the pathogen present, it's still going to be an issue. Or so, yeah, I don't see that being a limiting factor necessarily.
Okay.
So one last question. So if you have it, do you have it then for life? If you say it doesn't go dormant like a fungi tend to, right? So Sclerotinia, if you have it in your field, it can go dormant for a long time, right? We spoke about deep tillage. Does that give you a scope of a certain time frame that you sort of control it? So yes, you put it underneath in the soil, right? How long is that time frame, and should you deep till again within the next whatever amount of years, do you then bring it up again and it just sparks off again? Or is that a way to actually kill it off for, what is the time frame that you have scope of managing this?
Yeah, so I would say that no, it's not like Sclerotinia or some of these other diseases where you have it and it's going to be there for life and you might as well. No, it's not going to be that at all. With every year, like it's going to slowly like taper off, and then the deeper you till it, the lower the survival rate, right? So I would say you're fine. Ideally, if you can do a soy rotation, I think you're probably fine to go back into corn again after that. Just be cognizant that the disease has been present there and you just need to scout for it and understand.
So I'll add, because I think she was being asked, if your plant gets infected, then it becomes cold, will it go dormant in the plant? And the answer was no. In the field, the big key, because it's a bacteria, right? Bacteria, and this particular one doesn't spore up. So as soon as that organic matter is broken down, its shelter is gone, and it's not going to be competitive in the soil. It will be broken down as well. So that's why the tillage matters, is that you really are trying to get that organic matter incorporated. You're trying to get more of it shredded up and kind of buried in, and earthworms and whatever else is coming through to really break it down. That's the impact you're having. So if you expose it to nature, it won't survive long. Okay?
Okay, are there any last questions from inside the room? Bobby, you good? Then we're going to finish off with one last online question, and then we're going to give over to Steve just to do the closing remarks. So is I assume it's ultra fast growing hybrids more susceptible to Goss's wilt than medium growing hybrids?
As far as Say that again.
Ultra
Maturity.
Oh,
Yeah.
it's maturity.
Yeah.
Okay.
I didn't say it. The shorter ones are more.
Yeah, so it's is the shorter growers more susceptible to Goss's wilt than the medium or longer growers?
Yeah. So I think there's several things that could impact that. First off, germplasm, right? I don't know what the germplasm looks like for the different maturities. You might tend to have a little bit more susceptibility in the early years. That's always a possibility. But really what I think ends up happening, and we do this with our own inoculated trials, right? We plant by maturity and then we rate by maturity, because you have something that's a shorter maturity planted next to something that's a longer maturity. A lot of times that shorter maturity is going to look worse when it's planted right next to a later one. But if you go back in a few days, it's a maturity thing that goes into play. When you have them planted side by side, the earlier maturity might look worse, but if you wait a little bit longer, it's possible that the later maturity could also look bad as well. So,
Okay, so the growth stage plays a role there.
yeah, it does.
Okay.
So you kind of have to be careful with that. But it could just be also the genetics too, so that plays into that.
So the resistance in the hybrid there would play a role rather than the maturity of the
Right.
fast or medium grower.
Yeah.
Okay, good. And then if there's no more questions, I'm gonna hand over to Steve just to do a bit of closing remarks for us. Ladies, thank you very much. It was very informative. Afterwards, there is going to be a small lunch for the people that is in room. Sadly, for the people out of room, we don't have food for you. All right, thanks, Steve.
McDonald's.
So firstly, just want to ask everyone in the room and online to put our hands together for Samantha and Andrea. That was absolutely brilliant. I would also like to say thanks to Johan, Bibi, Lisa, Christian, and Jaco Bernardi for all the hard work that's gone into this for many months to make this happen. I think just very important, the disease is called Goss's wilt and leaf blight. We're all very lazy and like to refer to Goss's wilt. Just a couple of key points from this disease. It's a polycyclic disease, means it goes through many cycles in a season. It overwinters an infected material, and this overwintering infected material is key to managing this disease. Controlling, I see you avoided the word controlling, and you spoke about managing the disease. I think it's very important. It's disseminated by rain, wind, irrigation is key, and natural infection can occur, but often when there's mechanical damage is where we see the exacerbation of the infection. And it's important to look at the lesions and identifying the disease. So it looks very similar to northern corn, but we saw drought, stress, sun scald, and even nitrogen deficiency can often be confused with it. Looking at the immunostrip, if it's negative, the disease is definitely not present, but if it's positive, it could be Goss's wilt or a similar bacterial species. Obviously, when the infection occurs, early infection can have a very high impact. Later infection in the reproductive phase, we see a less damage occurring. And ultimately, the susceptibility of the hybrid will indicate the yield loss. The pathogen, so the Goss's wilt leaf blight, can infect multiple, has a broad host range, particularly the secondary host range. You're looking at the grass species, and wheat and oats as a potential host. And weed control is going to be key for reducing the inoculum in the field. Management practices include tillage, crop rotation, and again, controlling the hosts in the field. Just looking at what happened in the USA, we saw that with the P4 pipeline, we saw how the tolerance has increased through the years, and this is through the various screening which takes place. The grit blaster, I made a note of this particularly, is incredibly effective at screening. It's maybe something we need to look at locally in the agronomy team. And the work that's going to be looking at the correlation between the work done in South Africa and the work done in the USA will be critical going forward. The region, and I think this is very important, the risk of the region and the tolerance is key, and you spoke about how we position hybrids east and west. And all the agronomy colleagues online and in the room, there's going to be a lot of work for us going forward to ensure that we position our products effectively with this. Something which you mentioned is the pathogen was likely here for many years already. Very important that there will be engagement with government happening in the next, tomorrow in fact, and this is something which we would like them to be confirmed by them. There was an article recently published about this specifically. And then very important is advocating this message to our growers, being transparent about what we do and the work, and I think having two experts here is part of this. And everyone online and in the room, just to remember that there will be a session tomorrow here with industry bodies and government, again with our expert team. On Wednesday, the team will travel to Bothaville. On Thursday, it will be in Frankfurt. And on Friday, it will be in KZN in Winterton. So please share the message with your growers. Let them know that we do have these experts. There will be a lot of questions that come from them. Hopefully our team is now also experts on the matter. The team will be here until Saturday. They fly out Saturday evening. So if there are any questions which do pop up, please share them with Christian, and Christian will be able to share them with the team, and afterwards we will be able to share all the material which is discussed with everyone in the room and online. And with that, I'd like to close off and once again say thank you to the team and wish everyone a great day further. Thank you very much.